India is a country of 1.2 billion people, but only 1.5% own a car. On the roads, scooters and motorbikes rule, while the roads themselves seem to have none. It's common to see an entire family on a motorbike built for two. And on roads made slick by monsters, the world's cheapest car. But he'll have to battle skyrocketing costs, huge engineering hurdles, bad press, and violent uprisings. All challenges for the mighty Tata Motors mega factory. Soon expected to overtake China as the most populated country on Earth. It's already home to 1 in 6 of the world's people. 2/3 live in small rural villages, seemingly untouched by time. But ancient India is urbanizing at a dizzying speed. Despite that, only 15 out of every 1,000 Indians own a family car. For most, it's a dream, way beyond their reach. They make do with a family motorbike, or get a ride with friends. But that could change when Tata Motors releases the world's cheapest car, the Nano. It's the dream of company chairman and legendary tycoon, Sir Ratan Tata.
It hit me initially as I saw families riding on two-wheelers, the little kid standing in front of the father driving the vehicle, the mother sitting in the back, holding a child, and I thought, my God, this is a really tough way for someone to travel, both in safety and in comfort.
The Nano is planned, of course, to turn a profit. But Tata is also interested in helping to make India's roads safer. A motorbike here obeys basic traffic rules, or keeps an eye on their livestock. Not to mention some other unusual traffic hazards. But it's about to get a lot worse. The monsoons are on the way. For the next 3 months, these roads become skating rinks, riddled with potholes, surface flooding, and still ruled by cows. Rain and two-wheelers are a lethal combination, as Ratan Tata soon finds out himself.
So I just got through telling the driver, just stay a little bit away from that scooter because if it turns, it may slip. And sure enough, it did. And this whole family was all over the road. That was a very graphic demonstration of how dangerous it could be.
For years, Tata, a US Ivy League trained architect, doodles safer scooter designs during dull moments in meetings.
I doodled about trying to get roll bars and a roof, a way to give them an all-weather, affordable, but safe form of transport.
Tata soon realizes he needs to build a proper car. But at what price would motorcyclists buy in? In 2003, the cheapest car in India costs around 200,000 rupees, roughly 3 times as much as a motorbike. And this is it, the Maruti Suzuki 800. Tata wants his car to look more modern, but be closer in price to a motorbike.
The Financial Times correspondent interviewed me and he asked about what would this sell for, and I said about 100,000 rupees, and that became the headline. And I had 2 choices. One was to refute it, or the other was to take it on as a target. We chose the latter.
100,000 rupees is called 1 lakh. No one in their right mind believes that a 1 lakh car is possible. Especially not the chairman of Suzuki Motors.
Well, it had made some rude comments, if I may say so, Mr. Suzuki, and he said no, that was not possible, and he made a fun of the whole idea.
The challenges are formidable, but so is Ratan Tata. After college, he returns to India on the advice of the family patriarch, J.R.D. Tata, founder of Tata Motors. He works his way up from running a furnace at Tata Steel to running the entire Tata Group. It's a global juggernaut worth $100 billion. In India, Tata is everywhere. Tata hotels, malls, communications, and above all, Tata Motors, one of India's top 3 car makers, a world leader in trucks and buses, and now proud owners of British luxury brands Land Rover and Jaguar. But even for India's most powerful CEO, reinventing the car is going to be a gargantuan challenge. To make his dream come true, Tata has pinned his hopes on a purpose-built mega factory near the town of Sanand in the state of Gujarat. It's a sprawling 450-hectare complex of massive workshops, linked by roads and sky bridges. The workforce of 2,300 mostly get here by bus or a trusty motorcycle. The factory is made up of 5 main sections. The engine and transmission are assembled in the powertrain building. Sheet metal is pressed into panels in the press shop. The weld shop assembles the panels into a body, which is sent across a sky bridge to the paint shop. All the parts come together in the trim, chassis and finish, or TCF shop. When it gets up to speed, this factory can produce 350,000 nanos a year. It boasts state-of-the-art automation and over 130 robots that would be right at home in Japan. But to run them, they'll have to train a workforce of villagers. Just one of the many challenges the team must overcome. They're going to deconstruct the car as we know it and put it back together with fewer parts and at half the cost. They'll have to reduce the cost of everything from design right through to production. But it still has to be a car that people will want. It's a real conundrum. Safety, aesthetics, fuel economy and handling are all going to be important. But if they blow the budget to achieve them, the Nano will lose its unique selling point as the world's cheapest car. No wonder the design team is a little nervous.
The team came back after the meeting with Mr. Tata in 2003. Was really initially very much confused.
Well, there was a lot of doubt whether we can really achieve it. It was really a challenge. We had never heard of a price that low.
It was so challenging that I said, hopefully we can do it, but it will be the most difficult project in my life.
If they succeed, the team could make history. The Nano will be a people's car. India's answer to the Model T Ford. When Henry Ford introduces the Model T, the $850 price tag puts car ownership in the reach of millions of Americans. That's about $21,000 in today's money. Volkswagen is German for people's car. It goes on sale for today's equivalent of $11,000. The Nano is slated to come in at a quarter of that. Designing this impossible car happens at the passenger car division of Tata Motors near Pune. Pune is the largest of Tata's 5 plants. it has 20,000 employees. But hardly any of them know what's going on at the Engineering Research Centre. Codenamed Project X3. It's so secret, only a select group knows it exists. As soon as the initial shock wears off, they start thrashing out ideas.
So the team initially worked on lots and lots of concepts. How to make this car, whether the car should have doors, whether the car should be made in plastic.
We played with really crazy ideas, whether we can use composite materials, maybe paper somewhere, you know.
Or whether it should be a 3-wheel, 4-wheel, whether the engine should be in the front, engine should be in the rear.
But some of their ideas, like bars to stop people falling out instead of doors, don't sit well with Mr. Tata.
Well, they looked horrible. They looked as though somebody plucked an eye out and they were just empty sockets. And that led me to feel that probably a customer wouldn't want a half car.
Tata is adamant that the Nano must have 4 doors. Even 2 doors would greatly reduce costs. That'd be all right in the West, where single-occupant vehicles are the norm. But this is India, where people ride 4 to a motorcycle. They're going to put at least that many in a car. And for women in traditional saris, clambering into the back of a 2-door car simply isn't an option. Why is it more expensive to make a 4-door car? For one thing, it takes 3 production lines to make 1 door. And it starts in the press shop, where raw steel is shaped into panels. It takes 5 cast iron dies, each weighing more than a bull elephant, to make 1 door. The high-speed tandem press can stamp out 2 sets of panels simultaneously. Sheets of steel are fed into the press by forklift, much faster than the overhead cranes used in most press shops. Then, the tandem press gets to work.
First of all, you will have the basic shape of the car, and thereof the extra parts will be cut off. And subsequently we have the trimming, the flanging, piercing and other processes. In a minute, we can make max 14 panels.
The finished panels are inspected for tiny imperfections by hand. Only those that pass muster are taken to the hemming line, where inner and outer door panels are joined together. It's a job that takes 2 robots and humans to feed them. First, a robot applies a noise-absorbing foam between the panels. It presses them together and folds or hems the panels to join them. Robots help keep costs down, but achieving the Nano's 1 lakh price tag starts at the design phase. Despite the cost, the team manages to include 4 doors. Now they can turn their attention to the heart of the car, the engine. There are 2 important decisions to make. How big should it be? And will they put it in the front or the rear? Rear-engine cars are highly unusual. But for designers of compact cars, they have one very big advantage. It leaves room for more people.
It was actually my dream, you know, because I knew to make such a compact car with full space for 4 people, you can only achieve it if the engine is the back. It is kind of Volkswagen lesson.
But where the original Beetle's engine is behind the back seat, the Nanos, is under it. That means raising the roof, which turns out to be another advantage.
The lower his car is the more difficult entry, especially in India, maybe with different kind of dress or sari.
There are challenges too, such as keeping the engine compartment cool.
I think we will also better address the requirement of cooling, which is coming from the engineering side.
After many attempts, the team places air scoops behind the rear doors.
And it sort of shows that it's a rear engine, so it has a nice cooling duct created like a rear engine.
Also much better is this quarter here, clean.
Simpler. And yet make the car look much more sporty.
Designing the engine itself is a job for Tata's legendary engine designer, Narendra Jain. To keep costs down, he decides to go with just 2 cylinders.
You see, the 2-cylinder engines were stopped in worldwide in 1970s, if I remember.
There's one big drawback to a 2-cylinder engine. It's inherently unbalanced and prone to violent shaking forces.
In this engine, the 2-cylinder, both the pistons are going up and down at the same time. If we see there are 2 counterweights. This is to balance the mass of this piston and connecting rod which is moving up.
The weight of the pistons moving up and down is balanced by weights attached to the crankshaft. While the pistons move up, the weights on the crankshaft move down, balancing the vertical movement. But the crankshaft weights don't just move up and down, they turn around, which means the crankshaft now creates its own horizontal shaking. To counter that, Jain designs a single balance shaft. This weighted shaft spins in the opposite direction to the crankshaft, so it cancels most of the horizontal shake. Damping down the shaking with 1 balance shaft instead of the usual 2 means another cost saving. But will it power the car? To find out, they mount it on a simple frame, known in the trade as a mule.
So the mule is, like a very, very early pseudo prototype, or the first thing that you see. This is what it will feel like. It gives you the idea of what the car feels like when you drive it, when you turn it, when you try to push the engine.
The mule is the culmination of almost 2 years of work on Project X3. Showing it to Mr. Tata is a pivotal moment.
I drove mules through the cycle. The first one was very disappointing.
The mule is woefully underpowered.
So he drove and he was not very impressed. I mean, we were waiting at the test track, to hear his reaction, and people who were with him on the car said that he was not very thrilled when he drove it.
It's time for some fresh blood. Enter Girish Wag. He's just successfully developed a light truck called the Ace. The tiny 2-cylinder Ace is a smash hit. But can he do the same for the Nano? The first priority is to sort out the engine.
We increased the capacity of the engine, and believe me, this takes almost 9 to 10 months to do this kind of a job. We put it on a prototype again.
It was refined enough so that you felt that it didn't sound like a motorcycle with 4 wheels.
He came again, he drove the vehicle, and he said, I think now from drivability point of view, we are there.
The little engine that could comes together in the powertrain shop. Men, women and machines work together to make everything from the crankshaft to the engine blocks. The final assembly of the 35 horsepower engine is all done by hand. Skilled workers join the modest little power plant to a 4-speed manual transmission. This will see the Nano get an impressive 24 kilometers per litre, making it the most fuel-efficient petrol car in India. No point in making an affordable car that isn't affordable to run. The engine is also a lot cleaner than the polluting used cars and motorcycles it aims to replace. While the powertrain is assembled, a body is born in the weld shop. Joined to the press shop, The weld shop takes in 11 kinds of body panels, which will be welded together to form a steel unibody. Most cars are made like this, but steel was not Team Nano's first choice. One word: plastics.
Initially, when we started, we thought we'll go for a plastic body instead of a sheet metal. And the idea was to reduce the weight.
But it's an idea ahead of its time.
We found out that if we go for a plastic, we have the cost point of view, you are not better, you are worse.
And India may not be the right place for plastic cars.
In terms of Indian driving condition, in terms of the dentability, the sheet metal is better. If you have some dent, you can repair it very fast. You need not change the panel completely.
So steel it is. 130 robots in this ultra-modern mega factory weld it together with ruthless efficiency. But raw material prices increased 40% between Tata's announcement of a 1 lakh car and the start of production.
Perhaps the greatest fear in my mind was that as we transformed to a conventional process, that we would not make the price line that we had thought of.
For Tata, a promise is a promise, and it's up to his engineers to deliver on it. So how do they do it?
From our experience, I don't think there is a single magic bullet. We have to work on each and every part in the car and see how we can reduce the cost of that part, or eliminate some of the parts, or combine the functionalities so that finally number of parts come down.
They call this minimalist approach Gandhian engineering. Nothing goes unquestioned.
This is the fuel pump unit. This goes into the fuel tank. So there are basic 5 components here. One is the fuel pump, a pressure regulator, a rollover valve, a fuel level sensor, and this is the flange which holds everything and mounts everything onto the fuel tank.
To get the price of the whole unit down, they ask the supplier to reduce the cost of each individual component.
They propose the pump from the motorbike because our engine is very small, 2-cylinder, 624cc engine, so it makes sense that this capacity is enough.
For all their clever engineering, the designers are most proud of the Nano's looks.
The lamps are like eyes, a little bit smiling,
I like the idea of big lamp, Nikhil, because we have to have some element which shouts to the people and which shows character to the car. If not, we'll finish with plain surfaces and something.
Horizontal lamps and a curved bonnet give the Nano an almost human face. The team feels sure it's onto a winner.
We need a strong element, very singular strong element.
But Mr. Tata wants one more change.
This was almost a week after we signed off the final design. He observed the car and he noticed that the nose dived down rather quickly for the length of the car, and he thought that it'd make the car look snub-nosed.
He wants it to be 100 millimeters longer. At the same time, they have to move the wheels out to the very corners of the car to free up more space for passengers.
The car was so compact that we had a little bit problem to make nice shape. So this extension actually improved packaging, improved stability, and also improved styling.
But the changes mean pressure on the entire team.
And we really worked 48 hours a day. We had to work really hard then. And when he saw it, he was quite happy. And I think after 2 weeks, we had signed off the CAD concept.
Before they reveal the prototype in public, it must pass a punishing series of tests that simulate Indian road conditions. Tight turns for narrow city streets. A torture track as smooth as any Indian road. A 30-centimetre water trough mimics the monsoon floods. You could even take your Nano to the Himalayas. It handles steep hills and has been tested and approved at temperatures as low as -50 degrees Celsius. They're ready. It's time to show the people's car to the people of India.
Ladies and gentlemen, thank you for being with us on this memorable occasion.
While a holographic image of Tata warms up the capacity crowd at the Delhi Auto Expo, the man himself waits nervously backstage
If you want to name a moment of fear, that was truly it. As I sat behind the curtain, I kept thinking of all the things that could go wrong. And when I did drive the car out in a darkened hall, what struck me was the enormous amount of people there and the applause and so on. And it shook me up a bit. Overawed by the cameras flashing, and I'd never faced anything like that in my life. Probably never again anyway.
Tata needn't worry. The Nano is a smash hit.
The reaction at the opening was far, far beyond my expectations.
You could see hundreds of cameramen, hundreds of press people.
Flashbulbs going around, people clapping, and there was thunderous applause.
I don't know what people may have expected to see, but definitely they did not expect to see a Nano.
We'd like to acknowledge on behalf of the company what the team has been able to do.
It was really a great occasion, a great pride for all over the team members.
An experience which I would certainly cherish for my entire lifetime.
I remember a few colleagues behind me who had tears, had eyes welled up. And it was a great feeling. I can't forget that till date.
And against all odds, the team meets its price target.
We'll have a dealer price of 1 lakh only. That is because a promise is a promise.
Back at the factory, it's time to kick the production line into top gear. First stop, a good coat of paint. The paint shop is a short ride by Skybridge from the weld shop. The industry calls an unpainted car frame a body in white, or BIW. The doors and bonnet are clamped open so that the paint can reach everywhere. The BIW is thoroughly checked for defects. Then it's degreased and prepared for painting.
Once the body comes into the paint shop, then the body goes for the pre-washing. After the pre-washing, the phosphate coating is happening. After the phosphate coating, the body goes for the electro-coating.
The protective primer is bonded to the freshly prepared metal by an electric current. This coating is extra important in modern cars because the entire structure is made of thin sheet metal. Any corrosion could spell disaster. Spinning the body 360 degrees guarantees all-over coverage.
It means that coating applies to every corner of the body, not only from the outside, but also from the inside also.
Now the primed bodies are ready for painting. Once again, they're inspected. Then the insides are painted by trained technicians, while the exterior coats are applied by programmed robots. In this energy-efficient paint shop, all the paint coats can be applied in quick succession. The bodies are only baked once all the coats have been applied. The paint shop is one of the most expensive parts of any car factory. And this is the second time Tata Motors has had to build it. They built the first paint shop in 2007 at the original Nano factory in Singur, in the communist state of West Bengal.
We went to West Bengal because we felt that part of the country had been vacated by industry for some time. And I really believed that the government of West Bengal was genuinely keen on bringing industry back. So with a leap of faith, I convinced the board that we should go there.
But ownership of the land allocated to Tata by the government is disputed by local farmers. From the outset, they try to thwart construction.
We had a fair amount of people beaten up, material being stolen, walls being broken.
For 2 years, Tata holds out, but eventually the situation becomes untenable.
At one stage, I think at the height of the problem, there were close to 100,000 people outside the gate.
They were now just weeks away from opening, but it was too dangerous to continue in West Bengal.
That decision to close the plant was a very painful decision, you can understand it. I can't explain to you the feeling that we went through.
Much as it hurts them, they're going to have to move the whole shebang 2,200 kilometers to a friendlier home in Gujarat, on the other side of India. One already difficult project suddenly becomes 3.
One project was dismantling of everything in Singur. Another project was setting up everything in Sanand. And third project was to do some interim arrangement for production of some cars.
With 200,000 pre-orders to fill, some nanos will have to be made at another of Tata's factories. Meanwhile, factory head Ramesh Vishwakarma has to move the brand new $300 million factory, and he has to do it fast.
So my project head, Mr. Giriswar, asked me, Rameshji, can you do it within 1 year? So, that night I kept on thinking what to do.
What to do indeed. The robots are ready for work. Test production has started, but they have to pull down the factory and start again. It'll probably be the world's biggest ever relocation. And as if that wasn't enough, the project is now dangerously behind schedule.
We were a little worried because it was a Herculean task. Dismantle, shifting, installation and recommissioning, the total period was only 1 year.
It takes Ramesh 3,400 truckloads to transport the factory, lock, stock and barrel, across India's notorious roads. A single road accident could derail the entire project.
Such huge plans needs to be shifted, but we did it. We did it successfully. There was no loss of part, there was no damage, although we shifted 2,250 kilometers away from Singur to Sanand, but still we maintained the quality.
Now Ramesh faces a new problem. There are few skilled workers to crew the factory in rural Gujarat. They'll have to train hundreds of villagers in a specially built training centre at the factory. Trainees enter at 18 years. They'll learn basic skills, like painting techniques. You have to learn the correct movement before you're allowed to practice, with water. You have to learn to tighten bolts at any angle, to pick up and place parts in the right order, before you graduate to assembling a nano on your own mini production line. And in this hotbed of spirituality, you can't build a better car without also becoming a better human being. Every day includes lessons in responsibility and moral behavior. Within 5 years, these trainees are expected to become divine. They've just overcome 2 massive hurdles, only to be confronted by another. Some of the early nano models catch fire on public streets. It's a public relations nightmare. Team Nano swings into action, setting up a team of local and international experts to investigate the fires.
We said, let's look at it in a positive manner and let's do something even safer.
We did a very thorough investigation and analysis of the situation. We also got some forensic experts from abroad, from UK.
And they looked at all the incidents and they gave totally clean chit and said there's nothing wrong with the design of the car at all.
In cases, we had found that a foreign piece of cloth was left onto the exhaust system of the car. The customers had also tapped the electrical system for some accessories and that had also led to some short circuit in the electrical system.
In response, Team Nano decides to make the car even more robust.
On the exhaust system, we provided additional protection, and in electrical system, we added additional protection in terms of fuses, etc. Whatever causes we identified for the fire incidents on the Nano, we provided additional protective cover to ensure that such a case doesn't lead to car catching fire.
With the fires under control, it's time to celebrate. In June 2010, Ratan Tata officially opens his new mega factory.
It is a great occasion today to be here, and I hope that in the coming years, we will see the product on the streets and the roads of India, giving the people of India a chance to have personal transport.
Production of Nanos finally reaches top gear. They need to sell hundreds of thousands of Nanos to break even, and that required sophisticated automation technology.
We have 70% automation, 130 robots working in the plant. And in body shop, one body can be produced within 53 seconds.
The painted bodies arrive suspended from a monorail. In 6 short hours, they will drive out under their own steam. First, technicians install the fuel tank and wiring harness on the underbody. Next, the doors, which were painted with the car body, are removed to give workers easy access. Later, the automated system will match them up with the exact Nano body from which they came. On goes the front suspension. In goes the dashboard. The seats. And the steering wheel. It looks ordinary enough, but behind the wheel is another triumph of cost cutting. Modern cars have expensive steering columns that collapse on impact. Non-collapsible steering columns haven't been used in the West in decades because they cause nasty injuries in a crash. However, Tata's safety engineers wonder if there isn't a way to cut costs without cutting safety.
We can now say we don't need a collapsible column.
Now with this improved design, we could able to go ahead without the collapsible steering column.
Digital crash testing allows them to quickly and cheaply try out new ideas. They discover that instead of a collapsible steering column, they can use the front of the car to absorb an impact.
So in Nano, we had to cut costs. So one of the things we looked at was whether instead of going for a collapsible column, whether we could just make part of the structure deform a bit and not offer that high resistance to the chest.
And when they crash a real Nano, their findings are confirmed. The trick is having the engine in the rear.
It clears off the space in the front of the car. You know, the complete front space was available for crush. So in this case, having the engine in the rear actually turned out to be a big bonus for safety team.
Another big bonus is that rear engines are very easy to install in the factory. It slots in from below. The marriage of engine and body is more of a quickie Vegas chapel wedding than an elaborate church ceremony. It takes as much time to connect up the hydraulics as it does to bolt the engine beneath the rear seat. But there is one disadvantage. When the Nano's small engine is running hard, it can be quite noisy. And that noise isn't under the bonnet, it's much closer, under the back seat. Reducing the noise becomes the biggest hurdle in the entire Nano project.
So for this Nano, this is a unique kind of car where there is a rear packaged engine which is sitting exactly inside the passenger compartment.
In this soundproof chamber, the team tests numerous engine mounts and sound-absorbing materials to reduce the noise and vibration felt by the car's occupants. With each change, they measure noise and vibration levels all over the car.
After 3 years of hard work, we have solved all the issues, and right now the car is acceptable for the customer.
It's small, it's tall, and it's surprisingly quiet inside. In the TCF shop, these Nanos are only minutes away from their first ever test drive. Of course, before they can do that, they need wheels. They're one of the last things to go on, and like the rest of the car, they're small. The wheels are the final battleground in the war between designers and the Ghanaian engineers, who've spotted one last...
To convince technicians to increase it, even if it means it's slightly higher cost. But for stability reasons and also for, let's say, comfort of the drive, they accepted slightly bigger wheels.
But the technicians win the battle over lug nuts. There are only 3.
So when we started with 3 bolts instead of 4 bolts, we made initial calculation and it really worked fine. We thought for this particular maximum speed of the car, the 3 bolts could be sufficient, and really it turned out to be that way.
Finally, each Nano is reunited with its 4 doors. These people's cars are now ready for some people. Almost. Outside, the rain is taking a break. But it's added an extra level of difficulty to the test track. Every Nano goes through this. And they test the brakes the old-fashioned way. Tata Motors starts to deliver Nanos to tens of thousands of eagerly waiting customers. Finally, everything is going their way. But if you live outside the Indian subcontinent, don't look for one at a dealer near you anytime soon. There are no plans to bring the Nano up to stricter Western safety specs. In Europe and the US, Tata will instead offer a car based on the Nano platform. A concept car has already been unveiled. The Pixel is a futuristic-looking car made for city driving.
We have tried to bring in a lot of new concepts on that. We have carried forward the rear engine philosophy, like Nano.
The Nano itself has only been out in the market a short while, but it's been garnering many great reviews. And Tata Motors are quietly confident about its future.
I think it will turn into a big movement, I have no doubt in my mind, not just in India, but across the world.
It's been a hard road to travel, but Ratan Tata's dream is slowly coming true.
I will forever be respectful and recognize the effort the team made, because the real credit for the car and the heroes of this whole exercise are the team that put it together.